So what we have here is a set of objects in default Bryce grey and standard Bryce lighting at the moment. I'm going to modify the materials so they have no diffuse response and 100% reflection. So I've turned them all into perfectly reflecting mirrors. And then I'm going to go to the Skylab image-based lighting and I'm going to open a HDRI image by Horo, a medium resolution HDRI, a light probe. And I'm just going to use this as a backdrop. So I want to add it to the sky and get rid of the effect and specular and turn down the quality, so we're only dealing with it as a background image. I'm going to increase the intensity to 10, check out of here, turn the atmosphere off so it's not added to the sky. You can see now it's gone rather blue because it's being added to this blue colour, and I'm going to set that to fully black. So now we've got just mirrors reflecting the HDRI backdrop, and to all intents and purposes that makes it look like just an image that's wrapped around the scene. But there's a bit more to it than that, and the main problem in understanding the role of this backdrop and how it works with reflection is that the monitor that you're viewing this through is only low dynamic range. Once you get up to fully white RGB 255, 255, 255, you've essentially hit the limit of what can be displayed. So these areas here are actually a lot brighter in terms of the the rendering calculations. The values that are being operated upon are much brighter, but when they come to the monitor they have to be brought into range where they can be displayed. So even if these are fantastically bright, they can only look fully white. I can demonstrate this in a couple of different ways. One way I can do it is just to select the objects in the scene here, and if I reduce the reflection by 50, then half the light is reflected. But you'll still note that these highlights here look very bright. It may not be immediately obvious what's going on there, so I'm going to take the atmosphere, which at the moment is fully black, and make that fully white. And now you can see that the background has all but vanished. You can't see any evidence of it here. We've got a mixture though of a sort of grey, milky grey, which is 50% of the white, so default Bryce grey, and added on top of that is the HDRI image that's still visible. So if you extend this idea, so if we reduce the reflection to just 2% and then go into the image-based lighting lab and increase the intensity to its maximum value available, you get this effect. So it's almost done away with the reflection of the white, because the white now, the 255, 255, 255 RGB white, is only 2% of its original value, which is a very dark grey. And you could go further along the same lines, because, right, as I will show you, if we go into the Skylab and just change the intensity here to 1, and I'm going to export this image, it's a spherical map, so I'm going to export it as a spherical map, but as a bitmap file, so it's only got 8 bits per pixel, so it's going to be converted from the high dynamic range. I'll just export it as spherical, save that. Now I'm going to put it back on a sphere and then boost its ambience with extreme material response. But before I put it back on the sphere, I need to move it around a bit. So I need to find out where it's exported. Oh, there it is. Drop it into here and just need to mirror it and then use offset and move it across. So I'm actually effectively rotating it 180 degrees, and file and save as. I'll just save over itself, that's fine. Okay. I'm sticking with a bitmap image rather than saving as a JPEG, because if I save as a JPEG I'll get a lot of artifacts from this compression. You can see that the image is in there, but it's all rather faint. Now if I go back into Bryce, I don't need to use this as a backdrop anymore, because I'm going to introduce something else. So I'll just turn that off as a backdrop, and then it won't be taking part in any of this. So you don't need to worry about the HDRI now. It's effectively gone. It's not used as a backdrop and it's not providing any light. We just used it to export that. Now I'm going to create a default Bryce sphere and modify the material on this sphere. So the ambient channel colour is going to be the exported HDRI image in a bitmap format, with this set so that it was a very dark except for the bright patches where the fluorescent lights are. That was key to this effect. The next thing I'm going to do is a bit tricky. I'm going to get rid of the diffuse response and give it a massive ambient response by using extreme material response generated in the deep texture editor. So I need to go into the deep texture editor, into the library, and pick out from the basic library this check blue, because that's the one I'm going to convert. So if you were to use the same one, it would make life easier. Switch off color, switch off bump, modify it. So instead of square, it says distance squared in type. In mode, it wants to be minimum. Frequency wants to be -1. Okay. And octaves want to be 1. When you've done that, you'd trust me on this, this is a very high negative value. And we're going to use that to generate a positive value. So if I pick this component up here and drop it into there and just go back into noise again and switch this off now so that it's nothing, get rid of the octaves. So if we use difference between a very high negative value and nothing, the output is a very high positive value. Very high indeed. And then we can use the alpha scaling here to scale the response of the ambient. So we can tone it down a bit. So you can't, because it's high dynamic range, you can't really tell the difference here, but if I'm toning it down, because it's scaled down from 100% to 1% of this very high value. Right, now we give this a render off once I've wrapped it around the entire scene. So I enlarge that so it encompasses the entire scene, and we give this a quick render. Okay, so that's looking a bit funny for a couple of reasons. One, I've not made it transparent so we can't see the white through the background, so we can still see some colour value here. And two, this surface is now too reflecting for the intensity of this backdrop. So if I modify this material and make it transparent, where's transparent? Here. And then I'm going to turn off shadow casting. Not that we've got any light sources really doing anything in this scene. So now that vanishes as a backdrop. And then I remember, because this always happens and I often forget, that the default mapping mode when you bring a picture in is sinusoidal for some reason. I don't know why. It seems like a very strange choice, but change that to spherical. Okay, we'll get in there. And then modify the material response of these objects in the scene down to the lowest value that you can have for reflection, which I think is 0.2. And at this stage, we have an interesting effect. We have fully black essentially, because the reflection value is so small compared with the 255. It's you know, it's a fifth of 1%. So that's as more or less as fully dark as far as your eyes are concerned and the setup of your monitor. And we've got this intense reflection coming from somewhere in this white void. Now you would normally, to achieve this effect, probably consider using masking, but here it's been achieved by taking advantage of the high dynamic range output that it's possible to achieve, either through using an image, a high dynamic range image and the image-based lighting lab, or using extreme material response. You can get high dynamic range from the extreme material response, which is very useful for creating effects or for creating realistic reflections. Well, that's what I was thinking anyway. So that's the end of the video. I hope you found that interesting, useful, and you'll have a go at experimenting with this effect in your own renders.